discuss what exactly heap sort. So here the two aspect one can go. One is nothing but the max heap creation or the mean heap. We are going for the max heap creation. Let's go for the step one, that is creation of the max heap. This is what the unsorted order of the elements given for this array 15, 20, 7, 9 and 30. Obviously we will get the ascending order of the elements after applying the heap sort related steps. So step 1, we will just go for inserting one by one element. So 15, it's obviously 20 will be inserted at the left because we need to go for the complete binary tree formation. So this will be 20. After arranging it, it will look like this array, that is at the location 1. This is what element at the location 1, the next is element at the location 2, like this it will be arranged. So since 20 will be at the location 2, but after looking to this particular array, we can just sense out that the element which is at the second location is higher than the element at the location 1. And in order to prepare the max heap, obviously the swapping has to be done between these two. So after swapping, this is the result. Once we got this result after swapping, so 20 will be at the root, then insert the next element, that is nothing but 7. So 7 will be inserted obviously at this point because we need to go for the complete binary tree formation and its representation obviously. So once this is done, this is the next operation where we need to insert the 9. So after this the 9 will be inserted and the resultant tree will look like this. So this is what the 9 insertion. So 20, 15, 7 and 9. So here one can guess out that the element which is having the maximum value as acting as a root. After this insertion of 7, if we go for inserting 30, that is what the last element, let's insert 30. So 30 will be inserted obviously here, because once this left side is filled, then only we can proceed for this left of 7 filling and then right of 7. So after this we can just find out that the element which is 30, it is greater than 20, means the root. So it has to be swapped because of the condition. So here we can just swap it first of all with the 15 because its parent is nothing but 15 and which is less than 30. So after this first swapping, we can just go for swapping of this 30 with 20. So at last we can just check here, this is what the elements after this particular swapping, because we need to get the max heap. So once the max heap data structure is obtained, after this the second step is quite important where the deletion is done in the max heap. So this is the first element which we are going to delete over here, and that is at the location. So this 30 will be deleted. So if 30 is deleted, what exactly the scenario? After rearranging, means after this particular array, one can just check it. It is the value that is 30, then 20, then 7, 9 and 15. These are the elements which are available. So when we delete this 30, obviously the element at the last location, this 30 will occupy that location, and the element which is at the last location, that will occupy the element of 30. Okay, so 30's location will be occupied over here. This is how the scenario will become. But here again, whatever the elements we are observing over here, these are not satisfying the max heap criteria. So again, in order to satisfy the max heap criteria, we need to rearrange these elements. So here what will happen, 20 will be swapped with 15 because its parent should be greater. So here it will be swapped. So once this swapping is done, 15 will occupy its actual location. So this is how the resultant array can be obtained. So after occupying the result for max heap, then again we need to delete this 20. Means after rearranging the terms, let's delete the maximum term. So 20 will be deleted. So after deletion of 20, it will occupy the second last location. 30 is already been sorted, so 20 will be occupying this location. It means that 9 will be swapped. So 20 and 9 will be swapped. Okay. So this is how actually we can just check it. 9, 15 and 7. This is what the result. But out of these three elements, one can guess out that 15 is the largest element. So once this is done, we need to just take this 15 to the higher side or as a root, and 9 and 7 will be accordingly rearranged. So this has been done over here. After this, 15 has to be deleted out of these three elements. So if 15 is deleted, obviously it will occupy the third last location. So it will be here. Once 7 and 9 is remain, so again with the maximum consideration, the 9 should be at the root location. So it has been swapped with the 7. This is how the arrangement will look like. Once it is satisfying the maximum criteria, after that we can delete 9. So if 9 is deleted, the case is 7 and 9 must be swapped with each other, and this is how the final result of one can say the heap sort is obtained, and these are the sorted elements, and that is what called as a heap sort. So to insert the element, log n is the time complexity which we can observe, and to delete n elements, O of n log n, that is what the time complexity which we can observe. So to have the minimum time complexity, we can go with the concept called as a hippify. And obviously there are two aspects, again with the max hippify or the mean hippify. But the max hippify is quite easier to understand. So that is all about the heap sort. Thank you everyone. Thank you very much.